Hello and welcome to another episode of Ken Training. Today's training, what we're going to do is we're going to be working on a residential air conditioning split system with the furnace. Alright, so now I want to get into the checklist and the stuff that we're going to be checking. There's my website address right there. There'll be a link to it in the bottom of this video. Now, this is a brand new checklist that I just created. So you can see what I've got here is I've got a picture of a HVAC system. You've got the return air coming in, coming down the return duct right there. You can see the arrows. And then there's I have the red dots are where sample points are located. And then on some of the red dots you can see I've got them numbered. So this first sample point, which is just before the filter on the return duct, is point number 1. And then inches of water column is how much static pressure is at that location before the filter. So I'm trying to determine exactly what's going on the ductwork and to see how well this system is breathing. So we're going to do that, we're going to do sample readings with a magnehelic gauge. This here is a magnehelic gauge that I have. Luckily I did not have to purchase it, I already had one. This one goes all the way from 0 to 2 inch, but in reality you could just use 0 to 1 inch. But if I was going to purchase one, I would not purchase one of these. What I would purchase is one of the new digital ones. This one's 20 years old, so I just happen to have it, and that's why we're going to use it. And that is how we're going to fill in this information. And as I go through the system, I'll show you that. And then point number 2, the return air temperature dry bulb and return air temperature wet bulb. I have a special thermometer. Where is it? Right there. This particular thermometer here that I have will give us that information when we get to it. So we're going to go through and fill out this checklist and determine how everything is the health of the system. We're going to try to figure out our CFMs. Now, the CFMs are a tricky one because I don't have an anemometer. I wish I did, but I don't. Now I do have some formulas here. This is a airflow for AC. We'll go through that so we can get the AC. We're going to get some temperature readings, supply air temperature, cooling and heating, and the inches of water column at sample point 4, which is after the AC coil. We're going to get the delta T, which is the temperature difference, which is 0.3, which is that point right there, minus 0.2 over there. So we'll go through the whole thing and make sure that you got it 100%. To get the heating CFM, you can see here I can figure out the heating CFM equals the BTU output divided by parentheses 1.08 times the delta T. And we'll go through all that so that you get exactly what it is. Your delta T is right there once we fill that out. So we'll go through this entire checklist. So my system, just being a single stage system, 40 years ago, I think that's all they had for, that was just what they had 40 years ago. Today, you can get two-stage systems, variable speed systems. They have a plethora of different products that you can choose from. They've got mini splits where they're trying to sell you where you put in one condenser outside can feed 4 mini splits, which can be good and can be bad. It can be good because you can put one supply head in each bedroom and individually control that one bedroom with that one evaporator coil mini split, but then in addition to that, which they never discuss, each time you do that, the refrigerant and the condensate line have to be addressed at each of those locations, which can be a complete headache because your goal is from my perspective, your goal is to try to keep the refrigerant all within the least amount of areas as possible, because refrigerant is the section that portion that can leak, and what you're looking for is a sealed 100% tight system. Once you get a leaker, trying to do troubleshoot on where that leak is let's just say not fun. And sometimes you're just going to end up, replacing those components. So if you have 4 units, you have 4 additional components, 4 additional points of failure, more complexity to the system. The benefit is that it gives you individual thermostat control. Well, you could do the same thing with a single central AC unit, and you provide duct zoning. So there's so many different options today in 2019 that weren't available 40 years ago. They didn't have all this fancy things that you could do in the home practically. Today it's becoming more and more practical, where people are putting more and more emphasis on HVAC. Alright, and as long as I got this open, I should probably just show you what it looks like down here. Alright, so now that we've got this open, we can actually see what it looks like. There's the natural gas pipe right there. This here is the opening for the airflow to come up the chase from the first level. Now, let's see if I can show it to you. So that goes all the way down. And these filters, they just basically, once you get them lined up, they just kind of slide right in. Make sure that they don't get hung up here, and then push them back all the way into the unit there. Alright, so that filter is fine. What are you doing? Tico, what are you doing? Don't you get in trouble? The natural gas valve, so I shut my pilot off for now, because what I want to do is I just want to do some air testing. So that's where I'm going to begin. Now, this furnace, my expectation is that the blower fan motor is going to be the same speed for the fan, for the heating, and for the cooling. But I want to do some testing, and just in order to verify that. Plus, I want to check airflow. Airflow is extremely important when it comes to an air conditioning unit, because the system needs to breathe. For people who, as an example, they don't change their air filter. Their air filter, they don't even realize that they're supposed to change it. They run the HVAC system, and the system just clogs up the filter, and then you're going to run into a problem with a clogged filter. Okay, so we're also going to be filling out our checklist to check the system out and see how it's going. So the first thing I want to do is I want to go to the thermostat downstairs, and I want to put the thermostat in heating so that I can see the fan. Now the natural gas valve is shut off, so the flame isn't going to come on, so the furnace isn't going to start producing heat. Alright, so I started filling this out with the unit number, the date, my name, what the furnace input is, what the furnace output is, the AC tonnage, which is 4 tons, and the rated external static pressure. And I put down NA because we don't know what it is, because it's not labeled on the data nameplate. Now let me just show you a little bit. Okay, so when you look at this number here, and you look at 048, what each ton of air conditioning is 12,000 BTUs per hour. So when you normally see a number like 048, you take that number and you divide it by 12, and you're going to come up with 4 tons. So there's a high probability that this unit is a 4-ton unit. So there's your AC tonnage. Now, on the furnace right here, it should be an information about the rated external static pressure, but it doesn't have it because, let's see here. This just tells you from 70, this just tells you the heat rise from 70 to 100 degrees, a temperature of 0.1, 5 inches of water at that. Okay, that's the how much temperature rise we should get with a temperature with a 1.15 inch water column static pressure. I'm unclear if that's a supply static pressure or exactly what static pressure that is. and then there's your electrical rating right there. Okay, now I want to get some airflow readings to determine what's going on with that. In an effort to do that, we're going to utilize this Magnehelic gauge. Okay, so let's go ahead and bring the Magnehelic gauge over. Now I want the unit to be on in heating. When you use the Magnehelic gauge, this needs to be flat. So I want to make sure that that's flat as possible. Because it's going to affect that needle if that's at a different angle or something. So I just want to make sure that when I do this, it's very flat. Now on the supply fan. Okay, I want to turn this fan on, and I want it to be on in heating. Now normally without natural gas, because I have the valve shut off right now, without gas, normally you're not going to get your supply fan to come on because of this right here, this thermostat, and it's currently set at about 95 degrees Fahrenheit, okay? And I'm going to leave that alone, and what I did is normally these two black lines, one is connected on one side of the thermostat, one is connected on the other side of the thermostat. What I did is I bypassed it by putting in a double tap spade terminal right there. So this way I could put two lines on the same leg, bypassing that thermostat. So we are going to get, once I plug this in, the fan is going to start, and it's going to start in heating mode. Then I'll be able to populate my sheet with all the data. So that's exactly what we're going to do now. I've got an amp probe on here, so I can go ahead and put that on amps. So go to AC amps right there. I'm going to go ahead and plug this in. Okay, and you can hear the fan is starting up. Okay, so now that the fan has started up, now I want to get some readings and figure out what they are doing. Okay, so looking at my furnace chart, first reading that I want to get is this one right here, reading number 1, which is before the filter. I want to know what that is in inches of water column. So I know that my filter is in the back of the door right here. Shut this light off, put it at an angle. So I know that my filter is right under the door here because it goes, the air comes in and comes up. So what I did is I drilled a hole right there, and so it's on the other side of this plywood that this unit sits on. So that is going to be the same thing as a pre-filter reading right there because it's on the opposite side. So on the Magnehelic gauge, what I did is I took and just put a needle that you would use to blow up basketballs or footballs, and that is going to be my test probe. I don't have a pitot tube because I don't own one. So what I'm going to do is I'm going to put that down there. Hang on, I got too much slack here. Let me get this nice and flat, and I have to make sure. Now remember, when you're looking at the Magnehelic gauge, there's two readings. There's the high and the low. So the high is on the top, the low is on the bottom. So what I'm going to do is I'm going to go to the low setting. So this one here you can see is the high, and then the one underneath that is right there. That's the low. Because this is my expectation, this is below atmospheric pressure, I want the low. So the low is going to be the bottom tap. So I'm going to take my needle and make sure that it's on the low. So actually I have two needles. Let me switch. Okay. Here is my low pressure port. Make sure your hoses are not kinked at all. Then I'm going to take this, put it down into here, which is supposed to be getting the pressure that's down below pre-filter, okay? And then I'm going to see if this gauge reading moves. Now, watch the gauge. What I'm doing is I'm pulling it out, and then I'm going to put it back in, and then you'll see the gauge move as I put it back in. very, very, very slightly. Pull it out, put it back in. See how the gauge just moves just a very, very small amount. I'm at the very bottom edge of the scale. So if you're looking at those lines, it goes 0.25 to the left of that, it's 0.20, 0.15, 0.10, so it's 0.05. So pre-filter is 0.05. So that is the number that we are going to populate for this point right there is 0.05 inches of water column. So 0.05. The next one that we want, okay, so 0.05 right there. Then you have a filter, then there's the next point right there. We need to know what that is. And we'd like to get the return air temperature, dry bulb, wet bulb, and the inches of water column. So let's start with the inches of water column. On the side of the furnace, over here, I drilled a hole earlier so I could put my reading into. Okay, so now I'm going to take this, find that hole if I can. Okay, there it is right there. I found it. I'm going to go in. Now there's the reading on the Magnehelic gauge after the filter, before the fan. That number is 0.125. 0.125. I'm going to pull it out and then put it back in just to show you the needle movement. If I can find that opening. There it is. 0.125. So let's go ahead and write that down. That number is this one right here. That is this number 2 reading, and that is 0.125. Now, as long as we're here, let's get our return air dry bulb and wet bulb. I got my thermometer here. Vents are open on it, and let's go ahead and see what that is. Okay, so the dry bulb temperature is showing 82.7. Oh, come on. 82.7. 82.9. Okay, we'll call it 82.9. So we're going to put down here the dry bulb temperature is 82.9. Now let's get the wet bulb temperature. So by doing this, I have to hit the mode button right here and wait until that's the dew point right there. The dew point is 66. I don't want that. That's the wet bulb. That's what I want. So the wet bulb, 71.6. We'll call it 71.5. Oh, wait, is it still dropping? 71.4. Hold on. Pull the waist slightly. Okay, we're still on wet bulb. We're going to call it 70. It's bouncing around, but let's just call it 70. Hold on. It's bouncing around good. Alright. I don't want to wait here forever because I'm impatient and I want to get moving. I'm going to call it 72.1. That's it. Okay. So that is 72.1. That goes right here. 72.1. That's the dry bulb. Now, if we want to know the air filter pressure drop, we're going to take 0.125 and subtract it by number 1, 0.05. That is going to give you your air filter pressure drop. So let's go ahead and figure that out. So if I take my phone and go to calculator mode, clear that out, type in number, actually it should be 2 minus 1. That actually should be 2 minus 1. 0.125, 0.125 subtract number 1, 0.05, 0.05 equals 0.075. So that is 0.075. Now, that's pretty good. That's not a bad pressure drop across the filter. Mind you, I just cleaned it. Let's do another test. What I want to do now is I want to take and use the low and the high right across the furnace. So what I'm going to do is take the low, which is right here, I'm going to stick that in before the filter, and I'm going to take the high and I'm going to put that in after the filter and see if that reading equals this reading right here. That's what I'm going to do right now. I have another needle valve right here, so let me get that out of the package and give me a second to put. Okay, I got it hooked up so that the high probe is actually here, or here on the system. That's the high probe, and the low probe is here. The reason why that's a low probe, it's the lowest pressure in the system. It's just before the fan. Now, when I do that, this is what the reading is. It looks like it's 0.08. My mathematical reading on here is 0.075, pretty much the exact same number, okay? So this is it, just doing the math by taking each point individually, point 1, point 2, taking those points one at a time, and then just doing the math on the calculator. And then here is the actual reading, just plugging the low and high ports directly in, doing it that way, confirming that information. Let's continue on with our analyses. Now, we want to now get after the coil, the heat exchanger, and before the coil, okay? That's going to be point number 3. I want to know what that is in inches of water column. Now that is going to be a high pressure, not a low pressure. So what I'm going to do is I'm going to take out the 2 probes out of here. I'm going to take the high pressure probe, which is the top one here, and I want to put it between these 2 points. Now, on my unit here, what I did was I drilled a hole right there. Now, before I drilled that hole, I went through, first of all, I looked at the unit. If you look at the way the unit is constructed, you can see the liquid line is here. Let me get a flashlight. You can see this a little bit better. Okay. Now, this is the liquid line. My finger is touching the liquid line. This is liquid refrigerant coming in. It's supposed to be going to an expansion valve, some type of metering device inside of this unit. Actually, I don't think it's an expansion valve. I think it's a fixed metering device. That's my assumption. This here, where the insulated line is, that's the suction line where the vapor refrigerant is traveling back up. So here the refrigerant's coming down, here it's going up. The way that this coil, because of this construction, this is a horizontal coil. This is the condensate drain line that should be connected to a drain pan at the bottom. You do not want to drill into this drain pan. That is going to cause you leaking water. So you can't willy-nilly just drill holes in this thing wherever you want. You could hit the drain pan, you could hit the coil, you could hit something you did not want to hit. So what I did was I took these 2 screws out and bent this back. I left this hood in place, and and then felt with my finger, and I could tell that the drain pan started right here. So by me drilling here, I was below the drain pan, but in the airstream. So I was safe to make that drill hole right there. So that is what I'm going to use for my reading right now. So let's get the magnehelic gauge up here, make sure it's nice and flat, use the high side reading. The low side reading is just going to atmosphere, it's not going to go to anything, so I'm not going to plug that into anything, and I'm just going to plug in this high side reading right there, and you can see it come up right there on the magnehelic gauge. Now let's write that number down. That number is 0.35. 0.35 between these 2 points. There it is, pulling it out, and put it back in, do one more test. Double check. 0.35. Good. It's a little bit less. It's actually about 0.34. Well, 0.35. It's good enough. Okay, so that number 0.35 goes right here. 0.35. That's that number right there. Now we need another number. This number right here after the coil where it goes into the plenum. Now, here's the coil. This dot here is, this sample point here is before the coil. Now, I took out a screw right there, and that is where we're going to go after the coil, and it goes into the plenum. Okay? Could be anywhere up there, but since there was a screw right there, it was just easy for me to remove that screw and use that as my sampling point. This is going to be a high pressure, so I'm going to take the high pressure side of my meter, my magnehelic gauge. I'm going to put that in right there, and as I put that in, that is going to give me a number. That number is 0.15. Pull it out, goes back to 0. So that's 0.15. So let's write that down. 0.15 is this right here. 0.15. Now, we can determine the coil pressure drop by taking 0.3 and subtracting 0.4 from it. So let's go ahead and do that. So we'll do that just like we did the other one. What we're going to do is we're going to take point number 3, 0.35. We're going to subtract point number 4, which is 0.15. That's going to equal 0.2. So we know that the coil pressure drop is 0.2 inches of water column, okay? So that's not a bad pressure drop across the coil. The coil is not like plugged, where it's producing a plug of airflow. Now, we want to know what the amps are on the, right now we're in heating mode. Let's go with supply fan amps. Let's figure out what that is right there. So my meter shut off, but let's put it back on. Go amperage AC. There's my backlight right there. And right now the fan is drawing 3.83 amps. Okay, it's 3.83. So let's write that down. And that goes heating supply fan amps 3.83. Okay, now that we know that, we can figure out a few more things. Now we do want to know the total external static pressure. That's going to be 2 plus 3. So 2 is 0.125 plus 3, which is 0.35. Okay, let's go ahead and get that going. 0.125 plus 0.35, 0.35 equals 0.475. So 0.475. Now my unit did not have a rated external static pressure, but if you're at a 1/2 inch or less, which is what I am, that is considered good. I don't have a restricted airflow from a total external static pressure point of view, which is how you want to review this. Now, I want to do another check. What I want to do is I want to check external to the heat exchanger. So what I want to do is I want to put in a sample point low here and high here, and I want to see what that comes out at to see if it equals 0.475. So that's what I'm going to do right now. Okay, I got the low port, which is the low port is the one there on the bottom, coming down, and I plug that into the side of the unit, which is after the filter. Okay, and then on the high side of the magnehelic gauge, which is the top line, I got that coming down, and that is plugged into right there, which is on the upstream side of the AC coil. There is your external static pressure on the magnehelic gauge. That is at 0.5 inches. That's a half of an inch of static pressure, water column. That is a good static pressure. This unit is breathing, and it is allowing the proper amount of airflow with the fan in heating for CFM. All right, that temperature for the supply air heating temperature was 147. All right, so we're going to leave that, and I got the amps there. I actually have all my information for the heating. I want to go shut the thermostat off because the house is already super hot. So let me go shut the thermostat off and let that. We're back at the thermostat, and let's lower this setting to a normal heat setting. It'll be something like 72. And I'm going to go to system off for now. Now let's figure out the heating CFM. So what is the delta T? The delta T is 3 minus 2. So 3 is actually, okay, it's the same. I'm going to put down 3 is the same as this one, 147. So 147 minus 2, that is going to be dry bulb, not wet bulb. So 2 on the dry bulb. So we'll say 3 minus 2 dry bulb is going to be, let's see here, 147 subtract, we're going to take the return air temperature dry bulb 82.9, 82.9, that equals 64.1. So that delta T is 64.1. Now we know that the delta T is 64.1. We're going to multiply that by 1.08. So we're going to multiply that by 1.08. That is going to equal 69.22. 69.22. We need the BTU output. We know that's 80,000. We want to divide that number by 69.22. So we're going to take 80,000 and we're going to divide that number by 69.22. 69.22 equals 1155. 1155 CFM. Okay, 1155 CFM. So now we know what the heating CFM is. We'll compare that up against the cooling CFM and see what that is once we get into the cooling. But the heating CFM is 1155. Okay, so this is just helping us fill out our sheet here and get all of our data. Next thing we want to do is we're just waiting for the system to cycle down, and then we're going to throw on the unit in cooling and get that going. This is still cycling down. The fan hasn't shut off yet, so we're still not below 95. Okay, that concludes the video. So you saw the checklists. I had two checklists. This one here was pretty much for the AC, and the other checklist, which is this one here, is pretty much for the furnace. You saw me fill out both of them in great detail. If you want these checklists, you can request them on my website. There's a link down at the bottom for you to do so. I hope that this video was informative.